Ever find yourself, kind of blown away by how your phone just like knows to turn off the screen when you hold it to your ear, or like how your car somehow magically senses those parking obstacles? It's wild. Well, get ready to have your mind blown wide open today because we're going deep, like really deep into the world of microtransducers. They're these tiny, almost invisible bits of tech that are totally changing how we experience, well, everything.
Yeah, it really makes you think something so incredibly small having such a massive impact on, well, basically our entire lives. Pretty amazing, right?
Absolutely. It's like these little components, these transducers are it's a good word for it, like the secret language of modern technology. They're like these tiny interpreters acting as both sensors and actuators, which basically means they can pick up on changes in the environment and then, boom, react with some kind of action.
It's all about energy, really. Transducers, you see, they're these master energy converters. They take one form of energy, could be light, heat, movement, even sound, and they translate it, like a magic trick, into a different kind of energy. This is what allows our devices to actually sense and respond to the world, make sense of it all.
Okay, that's pretty wild, but I need a real-world example to wrap my head around this.
Oh, well, picture this. You're holding your phone, right?
Gotcha. Always am.
Inside that phone, there's this tiny, and I mean seriously tiny, MEMS microphone. That little guy, that's a microtransducer, and is listening to every single word you're saying.
No way. So it's like a little spy living in my phone.
Kinda. But instead of spying, it's working hard, converting those sound waves, which are a type of mechanical energy, into electrical signals. And your phone, well, it understands those electrical signals. That's how we can talk and text and, well, do all the amazing things we do with our phones.
Wow. It's funny to think that just a while back, microphones were these big, clunky things, and now we've got microscopic versions just hanging out and everything. What's the big deal with making things so small anyway? What's the advantage?
Miniaturization. It's not just about being cool, although it definitely is kind of cool. Smaller sensors, they're just naturally more sensitive. It's like, how can I explain it? Imagine trying to measure a tiny drop of water in a giant swimming pool versus a little teaspoon. You'd get a way more accurate reading in the teaspoon, right? Same idea with microsensors. They can detect even the tiniest changes in energy.
So basically, smaller equals more accurate. Makes sense. But tell me, what else can these tiny wonders do that their, let's say, plus-sized relatives can't?
So we've got accuracy covered, but they're also way more efficient. These microtransducers, they sip power, which is great news for battery life. We all want our devices to last longer, right? And here's the kicker. They can operate super speeds, meaning faster data processing, quicker response times, the whole shebang.
Okay, I'm convinced. Greater accuracy, less power drain, super fast operation. No wonder these microtransducers are popping up everywhere. But let's zero in on one type that I'm particularly interested in: microsensors. These little information gatherers are like the unsung heroes of the tech world, always sensing and reporting, quietly working behind the scenes.
Totally. They're everywhere. Our cars, homes, even inside our bodies sometimes. And they can detect some pretty amazing stuff, from the usual suspects like pressure and temperature to things like light, sound, and even the tiniest little movements.
All right, give me the rundown. What kind of real-world magic are we talking about here? Give me some examples.
Okay, let's start with something I'm sure you use every day, that magical proximity sensor on your phone.
You mean the thing that knows when I'm about to give myself a black eye because I'm holding my phone to my ear and it turns the screen off?
That thing.
Yep, that's the one. That little piece of genius uses infrared light to detect your ear. It's incredibly precise, only switching on when needed, which helps save battery life and prevents all those accidental pocket dials.
It's amazing. I never would have guessed there was so much going on behind something so simple. And that's just one example. Think about it. The touch screen you're using, the thing that knows when to rotate your screen, even the fingerprint sensor, all microsensors quietly working their magic.
Wow, it's mind-blowing when you really think about it. What's it like designing something so small and yet so incredibly precise? What are the challenges?
Miniaturization is a whole different ballgame. We're talking about components smaller than a human hair, sometimes even approaching the size of a single cell. It's crazy.
Seriously, I can't even imagine. They must require some seriously specialized tools and techniques to make.
Oh, absolutely. It's a fascinating field that pulls from all sorts of areas: materials, science, nanotechnology, even microelectronics. But hey, the results speak for themselves. These tiny components are revolutionizing everything from the phones in our pockets to how we approach healthcare and beyond.
Speaking of revolutionizing, that brings us to another crucial part of our micro-adventure, micro-actuators. If microsensors are the eyes and ears of the microscopic world, then these are the muscles, the movers and shakers, making things happen at this unbelievably small scale.
Right. And they're everywhere. And just like those sensors we talked about, these micro actuators come in all sorts of shapes and sizes, each one with a special talent. Some use tiny gears and motors for those bigger, more powerful moves, while others, they're all about those super precise micro movements relying on flexible structures like beams or membranes. Think tiny, delicate adjustments.
So we've got these mini sensors gathering info about the world around them, and these equally tiny actuators reacting to that info by actually doing something, making something move. It's like a whole new world of action happening at a scale we can barely even fathom. But here's where things get really interesting, right? When you merge these two sensors and actuators, that's where we enter the realm of, wait for it, micro machines.
Exactly. And trust me, that's when things get really exciting. But before we get ahead of ourselves and jump into that amazing world of micro machines, let's punt the brakes for a second and take a closer look at how these micro actuators actually work and why they're so special compared to their, shall we say, larger counterparts.
All right, so micro actuators, the tiny dancers of the tech world, making things happen behind the scenes. But seriously, paint me a picture. How small are we talking? Like tiny robotic arms or what?
Smaller. Way smaller. Think, like a gear so tiny you could fit hundreds on the head of a pin. Or a membrane, thinner than a hair, vibrating thousands of times every second.
Whoa, okay. My brain's trying to keep up. But why even bother with motion that small? Why not just stick with the bigger actuators?
Well, think of it like this. Remember how we talked about microsensors being more sensitive? Same idea here, that miniaturization brings a whole bunch of benefits. For starters, these little actuators, they're crazy precise, incredibly fast. They can make these tiny, controlled movements that bigger actuators could only dream of.
So it's like what, trading a sledgehammer for a scalpel?
Exactly. That precision, it opens up a whole new world, especially in fields like, say, manufacturing, or medicine even. Imagine these micro actuators carefully putting together tiny little components for electronics, or even, get this, performing surgery inside the human body.
Okay, now that's some serious sci-fi stuff right there. But I imagine working at that scale, it can't be easy. What kind of challenges do engineers face when they're building these things?
Oh, there are definitely challenges. One of the big ones is, well, figuring out how to get enough force to actually make something move at that scale. It's a real balancing act, enough force to get the job done, but not so much that you end up breaking the actuator itself or, whatever it's working on.
Makes sense. So how do they do it? What kind of tricks do engineers have up their sleeves?
Oh, they've come up with some pretty ingenious solutions. Some micro actuators, they use electromagnetism. Think tiny coils and magnets working together to create motion, could be linear or rotational. Others use something called piezoelectric materials. These materials, they're wild. They actually generate an electrical charge when you put them under pressure. Basically, they can turn vibrations into motion.
That's incredible. It's like they're taking inspiration from all over the place to create these tiny machines.
Absolutely. And the applications are just as diverse. We've talked about medicine and manufacturing, but they're also being used for things like drug delivery, super precise, and high-speed optical switches, which are crucial for telecommunications. Even these cool devices called microfluidic devices, they can actually manipulate tiny, tiny droplets of fluid.
Okay, my mind is officially blown. It's amazing how something we can barely even see can have such a huge impact on everything. But let's zoom out for a sec. Earlier, we were talking about micro machines. Those combine both microsensors and micro actuators together, right? What exactly makes something a micro machine?
Think of it like this. A micro machine, it's like a tiny, self-contained robot. It's got its own sensors, its actuators, and a way to control everything. It's like taking all the parts of a big machine and shrinking them down to, well, almost impossibly small.
It does sound kind of like science fiction.
It does, doesn't it?
Yeah.
But the amazing thing is, it's not fiction anymore. It's real. And it's already changing how we do things.
Okay, enough teasing. Give me some examples. What can these micro machines actually do?
One of the most promising areas is targeted drug delivery. Imagine a tiny machine, so small it can travel through your bloodstream, carrying medicine directly to, say, a tumor. That could completely change how we treat things like cancer.
Wow, that would be huge. What else is on the horizon for these micro machines?
Honestly, the possibilities are pretty much endless. Researchers are working on using them for environmental cleanup, even advanced manufacturing.
Right.
Imagine like swarms of micro machines cleaning up oil spills or fixing things at a tiny scale or even building complex products way faster and more precisely than we can now.
It sounds like we're on the verge of a micro-revolution.
We might be. And as we get better at building these tiny machines, the line between the microscopic world and our world, it's going to get blurrier and blurrier. What happens at the micro level, it's going to have a bigger and bigger impact on everything we do.
So how do these micro machines actually work in the real world? I remember seeing something in the notes about application modes for these things. What does that even mean?
Ah, good catch. Application modes, they basically describe the different ways these micro machines interact with their environment. It's a way to categorize what they do, what roles they play.
Okay, so what are some of the main ways these micro machines strut their stuff?
Well, the research paper talked about three main modes. We've got integrated microsystems, control of macro systems by micro devices, and, this one's a mouthful, VLSI of micro transducers for distributed control.
Whoa, okay, that's a lot to unpack. Let's start with integrated microsystems. What are those all about?
Imagine a whole lab shrunk down to the size of like a microchip. That's kind of what an integrated microsystem is. A little platform that combines all these different microfluidic components, sensors, actuators, even electronics to do really complex tasks, things that usually need big, bulky equipment.
Wait a minute, is this what they call lab-on-a-chip technology? I think I've heard of that.
Bingo. Lab on a chip is a perfect example of an integrated microsystem. They're amazing. They have the potential to completely change healthcare.
So instead of going to the doctor and waiting for days for test results, you could just, get a diagnosis in minutes using something the size of a credit card?
You got it. And because these devices use such tiny amounts of, say, blood or saliva, they're incredibly sensitive and fast, perfect for when time is super important.
That's incredible. It could make healthcare so much more accessible to everyone. Okay, but what about the other two application modes? Control of macro systems by micro devices, and that VLSI one, those sound a bit more, complicated.
They are a bit more involved, but trust me, just as fascinating. Control of macro systems by micro devices, it's basically using these tiny actuators to control bigger objects.
So we're not just talking about moving things around at the microscopic level anymore. These tiny actuators can have a real visible impact on the world we see.
Exactly. Imagine a micro actuator controlling a surgical tool with incredible precision, or a robotic arm, or even the wings of a tiny drone. The possibilities are, pretty much limitless.
Wow, that's pretty mind-blowing.
Yeah.
And that third mode, VLSI of micro transducers for distributed control, what's that all about? It sounds kind of mysterious.
VLSI stands for Very Large-Scale Integration. Basically, it means creating a whole network of interconnected microtransducers that all work together.
So instead of just one sensor or actuator, we're talking about an army of them all talking to each other and working together.
Exactly. Think of it like a micro-sized Internet of Things, where each transducer is like a node in a huge network. They share information and respond to changes as a team.
Okay, that's seriously cool. What would that look like in the real world?
Imagine the wing of an airplane. Now, picture that wing covered in thousands of tiny microtransducers. These transducers could sense even the smallest changes in air pressure, temperature, things like that, and then actually change the shape of the wing in real time to make the plane more fuel efficient.
So we're not just talking about small improvements here. These micro machines could revolutionize whole industries.
You got it. And the best part is, we're just getting started. As this technology keeps evolving, we can expect to see even more groundbreaking uses for it.
So we've talked about all these amazing possibilities, but I'm curious, how far along are we really? Are we just talking about, science fiction dreams here, or is this stuff actually happening?
Well, the amazing thing is, a lot of this is already in motion. Some of these applications are already being developed, some are even being used.
Wow, so this isn't just a pie-in-the-sky idea. These micro machines are already making a difference. That's really cool. Now, earlier you mentioned lab-on-a-chip technology and how it's a perfect example of an integrated microsystem. Can you, break that down for me a little more? What exactly is it, and how could it change things?
Okay, so imagine taking an entire medical lab, with all the test tubes, the equipment, everything, and shrinking it down to the size of a credit card. That's basically what lab-on-a-chip technology is all about.
Wow, that's insane. I can barely fit all my credit cards in my wallet, let alone an entire lab. But seriously, how does something that small actually work?
It's all about microfluidics. These chips use these tiny, tiny channels, called microfluidic channels, to move around minuscule amounts of fluids, like blood or saliva. They direct the fluids to different parts of the chip, where they can be mixed with other things, heated up, cooled down, or analyzed by the sensors.
So it's like a little self-contained laboratory all happening on this tiny chip.
Exactly. And because we're working with such tiny amounts of fluid, everything happens super fast. Imagine getting results from a blood test in minutes with just a tiny pinprick, all thanks to one of these lab-on-a-chip devices.
That would be incredible, especially for people who don't have easy access to healthcare, like in remote areas or in developing countries.
Absolutely. This technology could totally revolutionize healthcare, make it faster, cheaper, and available to everyone. But it goes even further than that. Think about personalized medicine, treatments tailored to your specific genes. These chips could make that a reality too.
Wow, it's like having a pharmacy on a chip. That's amazing.
And that's just the tip of the iceberg. We're only just beginning to understand what's possible with lab-on-a-chip technology. As we do more research, who knows what incredible applications we'll discover.
Well, I have to say, this whole journey into the world of micro-transducers and micromachines has been, well, kind of mind-blowing. It's amazing to think that something so small could have such a huge impact on our lives.
I know, right? It's amazing what humans can do when we put our minds to it. This technology has the power to revolutionize so many industries, to solve some of the world's biggest problems, and even, to change the way we live our lives.
It really makes you think about the future and all the amazing things that might be possible. So, what's next? Where do we go from here?
Well, I think the most exciting part is that we're really just getting started. There's so much more to discover, so many more ways to use this technology to make the world a better place.
It's like we've opened up this whole new world of possibilities, this micro-universe just waiting to be explored.
I like that, a micro-universe. And who knows what we'll find there. New materials, new forms of energy, new ways to interact with the world around us. It's an incredibly exciting time to be working in this field.
Absolutely. And to everyone listening, I hope you'll join us on this journey of discovery. Keep asking questions, keep exploring, and who knows, maybe you'll be the one to unlock the next big breakthrough in the world of micro machines.
Hear, hear. The future is small, but it's full of possibilities.
And on that note, we'll wrap up our deep dive into the incredible world of micro transducers and micro machines. It's been a wild ride, and we can't wait to see what the future holds for these tiny titans of technology.
Until next time, keep exploring the micro-universe. There's a whole world out there just waiting to be discovered.